Welcome everyone to RAG Time, Evaluate RAG with LLM Eval and Benchmarking. I'm Amber, an ML growth lead here at Arise, and we are joined by Mikio, our head of open source. So if you've experimented at all with our Phoenix open source offering, Mikio is the brains behind the operation and can get your questions answered if you join the Arise community Slack and join the Phoenix support channel. Sarah is going to be dropping links throughout our presentation and throughout the Code Along workshop. So let's go into the overview. So we're going to start with a 10-minute presentation. So those that are new to RAG and new to kind of response and retrieval evaluations. And then we will get into the Code Along notebook, and we will dive into some applications of RAG and troubleshooting these retrieval evaluations. Again, if you're new to Arise, new to our open source offering Phoenix, Arise is an AI observability platform, and we've released a lot of capabilities around LLM evals recently. So sign up for our Arise community, check out our Phoenix repo and our Phoenix documents, and let's get it kicked off with just some of the pros and cons of RAG. So RAG, Retrieval-Augmented Generation. If there's folks on here who have tried out RAG, let us know, because we're curious for how many people are just getting introduced to RAG, how many people are looking at it as a possible solution to their troubleshooting workflows, and how many people have even implemented some of those advanced techniques. So we're curious like where people are, what people are wanting to learn about RAG. What I would say is the most common pro people are seeing is that once you've tried some prompt engineering, like some zero-shot learning, even some few-shot prompts, that search and retrieval methods like RAG have really boosted performance in your LLM application process. So you can leverage LLM capabilities with proprietary data as well by storing all that kind of private information within your own servers and then giving information to the LLM by using RAG. What's great about RAG is you're seeing a ton of new information come out on these advanced techniques. But what's also a little troublesome about that is you have to constantly be aware of this new information that's coming out. Mikio is constantly sharing new updates on RAG and search and retrieval methods and new papers and research, and it's great. But if you're not properly monitoring your LLM application system and the retriever and the retrieved documents that you are getting from a RAG application, there can be a lot of points of failure in the application, especially if you want to put this into production and use it in the real world. So just a brief, I see we're getting raised hands. I would just put if you have questions, just put them in the Q&A for now, because I'll be able to go back in and answer them too as Mikio is going through the Code Along notebook. So how does RAG work? Essentially, you have your offline and online processes. So offline, you're storing all this information. And then online, you can have a user query. That query then gets embedded, and then you use a distance metric like a cosine similarity to see where in this vector space that user query is in reference to all those documents that you stored. Once you see what documents are the closest to that query, you can retrieve those documents, feed all those documents and the user query to the LLM. Using prompt engineering, you can generate a great response for your user. Now, the overall LLM application process is getting that user query a good response. And if you're getting good responses for your queries, that tends to be overall success. You can get user feedback, you can get response evaluations, but you really have to monitor this entire LLM application to make sure everything is running smoothly, especially if you get a bad response, then you have to troubleshoot and work back to figure out where that problem actually lies. And that comes in kind of traditional LLM metrics that we've been seeing. So hallucinations, really popular, correctness, really popular ones to be evaluating those responses. And then for RAG and actual retrieval and ranking metrics, kind of traditional precision, hit, NDCG. If you have more questions on those, we're going to be going through those metrics because you'll be seeing them in the Code Along. See, we are getting... Okay, thank you. Yeah, thanks everyone for your questions. Yeah, just keep putting those in the Q&A. We also have people joining from Italy and El Salvador, so welcome. For response evaluations, we most commonly see these as kind of a binary classification. While there are many others, binary has been the most common one we've been seeing around QA correctness, hallucinations, and toxicity. So response evaluation are essentially going to measure the appropriateness of the response generated by the system when that content was provided. For retrieval evaluation metrics, these assess the accuracy and relevance of the documents that were retrieved. So your NDCG, we actually have a great blog post that was on Towards Data Science, how to calculate it, and the functionality of normalized discounted cumulative gain. I'll be saying NDCG the rest of the time. Sarah will drop that link. And essentially, you want to use positional metrics like this to take into account the position of the relevant docs. So that way you can measure the effectiveness of your top rank documents. So the closer those relevant documents are to the top ranked documents, the better. Hit rate, so the percent of queries that have relevant content. And the hit is going to be binary. So every query that you ask, either the relevant document was there or it wasn't. So a hit's kind of like a true or false, like was this information available? And then precision at K, precision is going to be the percent relevant documents up to K. If you just see precision, then it probably means K is the entire list of retrieved documents. All right, just a few example workflows to go through. And if this is seeming like a lot, Mikio does break it down in the notebook. This is just some background information. Also, all of this will be recorded. Slides will be able to be sent out. If you're in our Rise community Slack, you'll get first access to all that information. And we will be putting this into a course. So we have about 3 or 4 LLM specific courses available for free. The Arise University courses. Thanks, Sarah. Sarah just dropped the link for our Arise University courses. And so this will be available and you can get a certification for RAG. Just going through these example workflows, if you have an LLM application system and you get a good response, that's essentially what you want, right? That's the goal. So, okay, that's great. You get a bad response, and then you have to figure out where you're actually getting this bad response from. Are you getting this bad response because your prompt is making things sound weird for the user? So essentially, it's saying, okay, I'm actually getting all these documents, like my retrieval metrics are looking good. The documents are there, they're being provided to the LLM, but I'm not getting the right response. So that's when you have a response issue and you need to do some prompt engineering, maybe even just change out the model you're using. We do this a lot with the Arise's prompt playground, where you can change out the model, change out parameters, and get better answers. But the scenario that we're finding is more common, especially if you're using RAG, is that you have a bad response and you have a bad retrieval metric. Like you have a low hit rate, you have a low precision, you have a low NDCG. So the documents aren't being retrieved. The most relevant documents aren't coming to the top, and that's making it hard for the LLM to give a good answer. So if the LLM does have access to this relevant information, you might want to try some advanced techniques like using chunking, using improved text extraction methods, testing out different embedding models. If your NDCG is low, that's when you might want to experiment with re-ranking. So there's a lot of different issues here, and it does matter what metric you are using. But this is a great way to kind of go through kind of top of mind for if you're having a problem, what kind of problem are you having? But now I'm going to pass it over to Mikio, who will actually go through the most common challenges that we are seeing with RAG and the troubleshooting workflows that you can run yourself and be able to kind of surface up these problems and what you do when those main ranking metrics are low. All right, Mikio, I will pass it over to you.
All right, thanks so much, Amber. That was a great intro. So we might go over some of the same stuff a little bit, but 2 times is always good. So as part of this notebook, Sarah has probably shared it out already. It's also in our documentation as one of our use cases. So if you ever lose where we're at, you can go to our use cases and go to evaluating RAG with Evals and click on this collab link or kind of follow along. There's also, if you don't have access to OpenAI, we also have a demo site. It's phoenix-demo.arise.com/tracing, and you can kind of follow along with some of that as well. So today's agenda is one, we're just going to try to understand kind of how RAG works. We'll look at actually the traces of what a RAG application might look like, so you can kind of understand how it's working under the hood. We're actually going to build a RAG system. We're going to take advantage of Llama Index in this case, but you can use RAG with your own framework. You can do it with LangChain. You can do it with DSPy, Ratatouille. There's a bunch of cool ones coming out these days. But today we're going to use Llama Index. And then 3, we're going to evaluate that RAG pipeline with Phoenix evaluations. So what is Retrieval-Augmented Generation? So basically, TLDR is that, LLMs are hugely powerful. They're trained on massive data sets, but these will not include the specific data, like things like your company knowledge base or documentation. They also stop at a certain point, right? So, if OpenAI stopped training GPT-4, let's say last December, then it's not going to have information about stuff that's current, for example. And so RAG is kind of a hack, actually. It's being able to add additional information to tell the LLM about more recent information or private information and be able to let it reason on top of that. But as kind of Amber mentioned, it's actually an amazing hack that actually lets you improve the performance of your application and tailor it to your use case. And so we see it as the #1 use case of building LLM applications is being able to pull in extra context and be able to perform synthesis on that. So how can you store that extra information? Well, we need to be able to pull relevant information based off of a query made by a user, right? So that query, as Amber mentioned, needs to be searched on. And a lot of times that gets searched based off of using embeddings, based off of similarity. Data can be structured, things like text to SQL do this. It can be unstructured like text or images, and also calling programmatic APIs as well. Then that information is kind of pulled in. As Amber mentioned, there's kind of a prompt, but then also the relevant data is inserted into that, and then there's a final synthesis step. So there's kind of 5 key steps to building a RAG system. First, you have to take the pre-existing information, whether those are PDF files, whether they're websites, whether they're databases or APIs, and we need to load that into our system. And then we need to take that, break it up into meaningful pieces. And in our case, we're going to use embeddings to create an index. This is kind of a lot of times called a knowledge base or a vector store. And then we need to store that off. We need to store it in like a cloud storage or potentially a vector store, for example, like Pinecone or Weaviate. And then when we are doing synthesis, we need to be able to query that information. So given whatever indexing strategy you've taken, we need to make the LLM be able to have access to that data. And then today we're going to focus on evaluation, right? Which is the kind of the critical step that doesn't get talked about as much, but a critical step in any pipeline is checking how effective it is relative to other strategies, or when, knowing that the changes that you're making are actually improving your overall system. So evaluation provides an objective measure on how to have an accurate, faithful, and fast response time to your queries. So with that, let's get started. I've already pre-installed it, but we're going to install Arise Phoenix as well as Llama Index. This little experimental tag is actually going to give us access to evaluations. This will be kind of moving out of experimental very, very soon, but just for now, you're going to have to also install experimental. We're going to install these packages. We're going to apply Nest Async IO. This is just to be able to run asynchronous code in the notebook. It's going to make our evaluation super fast and concurrent. So that's what is there. And then the first thing we're going to do is we're going to launch Phoenix. And Phoenix is a really cool application that runs kind of alongside any notebook or any application that you might be running. And it automatically collects the information privately, securely for you to use to analyze, but also evaluate. And so now if you launch this application, I'll launch it again for you just to prove that I'm running it. It runs a little server in your notebook. And if we click on this, you'll have your own instance of Phoenix running here. Obviously, there's no information because we haven't interacted with an LLM application, but it's a really cool little companion application that's running alongside your notebook. Next, we're going to call this method in llama index to tell it to send all its information to our instance of Phoenix. So we're going to set a global handler and point it to arise Phoenix. So we have kind of a proprietary integration with llama index, but you can also trace a lot of other things like OpenAI and Bedrock models, DSPy, things like that as well. Next, so this tutorial does require an OpenAI key. I'll give you a little rationale for why we're using OpenAI today. OpenAI obviously has embedding models. It also has GPT-4, which is a great LLM as a judge. I wouldn't say there's many other models that are at its capacity. Certainly Gemini and some of the Vertex models are coming up to that level. But for today, we're going to use OpenAI for those two reasons. One, because it just lets us get direct access to embeddings, but also because it's a great evaluator as well. Next, we're going to download the document that we're going to perform RAG over. So today we're going to use Paul Graham's essay. Hopefully you're a little bit familiar about who Paul Graham is, but it's a little bit of a story about Paul Graham, and then we're going to ask questions about it. So now that we've downloaded that file to our local notebook, we're then going to use llama index to parse out that essay and build chunks of documents and embed them. And then we're going to store it in a local file as a Vertex vector store index so that we can perform queries. So we're going to perform that. And so now what this is doing is it's splitting up that essay into smaller chunks, chunk sizes of 512, and then using OpenAI in this case to embed them. And sure enough, if we probably go over to our Phoenix, we'll see that embeddings were called to generate embeddings. So each one of these took chunks of our embeddings and created chunks there. Okay, cool. So now we have a set of these documents. Now we're going to query llama index using this vector store index. So let's perform one of these queries. So for example, if I just ask this question to ChatGPT, what did the author do growing up? It would probably be not tailored to your use case, right? It'd be like, who are you talking about? But because we're performing RAG, now we have a response that says the author growing up worked on writing and programming. They wrote short stories. So you can see that it already kind of is tailored to the use case that we're looking for. And just to kind of see how that works under the hood, now we have a query, what did the author do growing up? And here we have the answer, the author growing up worked on writing and programming. And so now we have the inputs and outputs of that RAG system. And what's really cool about Phoenix is it's actually traced the internal state as well. So now we can see that a retrieval step was created. In each case, it retrieved two chunks of documents, so two parts of the essay. You can get the metadata about that parts. And we can also see the cosine similarity that's being used. So the cosine similarity here of the first document is 0.82, and the second document, the cosine similarity was 0.81. Now we can see how these documents were passed along into a synthesis step, and then finally calling an LLM. So actually, just to go back, you can see that ADA2 is being used as an embedding model. So it embedded the query and then did a similarity search. And then finally, in the synthesis step, those documents were kind of put into a prompt template. So there's a prompt template where it says you are an expert QA system.
And
that
Mikhail,
context,
we are getting a request just to increase the font size.
Of course. Yeah, thank you. Sorry about that. Used a very small font size. But here you can see there's a prompt template, right? This is kind of baked into llama index, but I'm sure you can override it. And that context, those two pieces of documents, are now put into the middle of the prompt to perform a final synthesis step using GPT-3.5 Turbo in this case. And you can also see that Llama Index has a system prompt, right? So it has a little bit of guidance on top of it as well. And then you can see the chat completions as the final step there. So now Phoenix automatically kind of tracking what's going on internal to your system. Cool. So we can prove out like the same thing is basically going on with Llama Index. So Llama Index also has a way to get the first text node and the second text node. But the great thing about Phoenix is we don't need to actually manually get that code. It's already available and being collected for you. So we already kind of looked at Phoenix. Now, what's really cool about Phoenix is because it's just running in this notebook, all that data that you want to get and do analysis on is automatically collected for you. So at any point in time, you can actually call the active session that is Phoenix and actually get a data frame of all the spans that we've collected. Spans being a unit of measure of a span is derived from a span of time. So it has a start and an end time, but then it also has a bunch of attributes on top of it. And so, oops, wrong order. So now you can see that you can get all the rich information that you had collected in Phoenix also in your local notebook. So now we can see that we have a bunch of spans called retriever, and in each one, there's the question as well as the list of documents that were retrieved. So if we just want to kind of narrow down to that, we can take that spans data frame and filter it down to just the ones that have documents. And then now we just can have like a data frame of both the input that the query that the user made, as well as the list of documents that that was used to perform RAG. So that kind of starts off the data collection side. So now you can start understanding how you can actually start extracting data from Phoenix to use it for evaluation. So evaluation, obviously, and there's this terminology out there called EDD, should really be the primary metric for assessing your RAG application. It determines whether or not your pipeline will produce accurate responses based on the data sources and the range of queries that you're going to see. While it can be kind of beneficial to look at the nitty-gritties of each query, this approach at kind of large volume is going to be really hard. You're not going to be able to handle edge cases and failures. So basically, you need to have a more effective, established suite of metrics and automated evaluations. And these tools can provide insights into your overall system performance and can identify like specific areas that might require a little bit more scrutiny. So kind of like what Amber mentioned, in a RAG system, there's two evaluation techniques that we take advantage of. One is retrieval evaluation. So these are assessing the accuracy of the relevance of the information coming out of your vector store or your retriever, as well as the overall response evaluation, right? Like measuring the appropriateness of the response generated by the system when the context was provided. So these are things like, did the LLM hallucinate even though it was given a bunch of context? Or did your LLM actually answer the user question? Which are also can be a good measure to track over time and in large volumes. So
we do have a few questions related to something you might want to, I know you're excited about, is what happens if Phoenix fails? Are there any databases that's going to be stored? Can it be self-hosted?
Yes, you can self-host Phoenix if you like. Definitely can give you documentation. You can always extract the data and save it off to disk. Obviously, data is gold for us evaluators. So you can always save this data off. And also we have like a bunch of persistent strategies coming out in the near future. But you can always just save off this data. Data frames are great to be saved off in Parquet files and things of that nature. So.
Perfect.
Cool. All right. So, we just talked about kind of being able to, that data is gold, right? But we basically need to produce some data. We only have one query and we don't want to type in a bunch of queries. So what are LLMs great at? Well, LLMs are actually great at creating synthetic data for us. Um, you know, it's sometimes worthwhile creating like real data and actually polling. We do this at Arise a lot. We, ask a bunch of people to create us some real queries, but an LLM is also great at doing that. And so what we're going to do is we're going to take the chunks of documents that we ingested into our vector store, and now we have this as a data frame. And now we're going to feed this into an LLM to produce us kind of hypothetical questions about this so that we can make sure that our retrieval system is working correctly. And so here I've created a little bit of a prompt for us. If you have a specific use case, you can change this prompt to however you want. But in this case, we're saying, hey, LLM, you are a teacher professor. Your task is to set up 3 questions for the upcoming quiz and examination. These questions should be diverse in nature across the document. Restrict the questions to the context information provided. And I've given it a little bit of guidance at the end, output it as JSON and give us the keys question 1, question 2, question 3. And so now we're going to use the Phoenix evaluation module. It has one particularly called LLM generate. So it can generate any information off of Pandas data frames. And you can actually process the information after the fact. And so in this case, we're going to use GPT-535 Turbo because we don't need to use GPT-4 to generate our questions. We're going to run this concurrently. So we're going to spin up 20 workers. It's going to be super fast. And then we're going to be able to get that data. And so now I'm going to click, let me get the prompt. And now, we have 58 documents. And so we're generating 3 questions per document. And we're going to have our golden set of query context pairs. So now let's kind of look at that. So now we have, for each chunk of documents, we have 3 questions, right? So what is the 2 main things the author worked on? What was the language the author used to write? What was the author's clearest memory? So you can see, like, you can create synthetic data really, really quickly. And this is a really good way to kind of get started evaluating your retrieval system. We're going to run one more cell to just kind of stack those questions together and combine them with the context. And then now we have a complete data frame of kind of the chunks that we have and then the question that we want to ask for that. So now, great, we have 3 times 58 number of questions that we can use to evaluate our RAG system. So LLM is a great way to produce synthetic data. Cool. So I'm just going to do a little reset on Phoenix just because we have a bunch of stuff in there. So I'm going to close it and then restart it. And now if we open up Phoenix, we should have kind of a clean slate here. So obviously, if you wanted the previous information, we should have saved it off. But we've done a little bit of a hard reset here. And then in this next step, we're going to take kind of the questions that we generated in our previous step and run those queries through our RAG system. Now, if you're being a little bit cost conscious, you can cancel this at any time, just get enough queries in there that you're happy. I might run it for a little bit longer. So now we're using Llama Index to ask questions, and then the LLM is responding to each one of these. So I'm going to let this run a little bit. And what's really cool about Phoenix is you can kind of see these questions stream in, right? So they automatically come through. We can take a look at a few of them. So, in each one of these, you can see 2 pieces of documentation being pulled out. Those are being pulled into a final synthesis step. So all the information that we're going to need for evaluation is currently being collected. But, you can kind of see just with it would be really, really taxing to be able to go through these and read each document and see if it's relevant to the input query, right? Like it would take a lot of manual QA to do that. So in order to do that, we're actually going to take advantage of an LLM. I think we have enough. So we have about 34 questions that we've executed.
And Mickey,
so I'm just going to
clear up for folks the example creating the synthetic data. Someone thought it was, yeah. So where exactly were the questions generated from? I think that's what we have a question about in the community.
Yeah, so just to rehash what we had done, we had all the chunks of essays, right? So there's like a little passage maybe about when Paul Graham was, in France, for example. We then passed that into this prompt template, and then we asked the LLM to pretend to be a teacher or a professor and generate like quiz questions for that. So it's actually simulating being able to generate queries for you. And we generated 3 questions for each one of our documents. So we're basically creating like a list of questions that we know that our LLM system, our RAG pipeline should be able to answer. Does that help answer the question?
Yes, that's perfect. So your LLM is acting like the teacher and it's generating the questions.
That's right.
Thanks, Vicky.
Yeah, cool. All right. So now well, we've got all this information. Now we can actually kind of get those retrievers, right? Like we want to get access to this step. What is the questions and the documents that were retrieved from each one of those steps? And so Phoenix has this built-in convenience method called get retrieve documents off of its evaluation module. And so we're going to run that on our active session. And now we get all the rich information that we see in Phoenix, each one of them having the question that was asked, as well as the reference text. So this is the document that's being pulled out, as well as the document score. So this is the cosine similarity that was given to each one of those documents. And so now we have a great data set that we can run evaluations on. So Phoenix's LLM Evals helps us evaluate relevance of retrieved documents. So we're going to run our relevance evaluator because basically we want to know for each one of these rows, is this chunk of documents relevant to the question that the user asked? In this case, we're actually going to use GPT-4 preview, kind of like, I think half, or I might be wrong, it might be like a quarter of the price of GPT-4, but a great judge of this kinds of stuff. You can use other models, but we like GPT-4 because it's the most reliable. So it's kind of a trade-off depending on what you want to pick, but we're going to use GPT-4 preview. And while this is running, just to give you all these evaluators that we have built, these kind of are pre-built into Phoenix, but you can also customize your evaluations to your heart's desire. As well, but each one of these have been benchmarked against different models. So for example, our hallucination of evals have been benchmarked against GPT-4, GPT-3.5, Claude V2. So you can bring your own model and you can also bring your own evaluations as well. But we have a bunch here that Amber already kind of went over: hallucinations, QA relevance, toxicity, things of that nature. All right, great. So
And
great.
Mickey,
So
we did get a question like going back to those metrics, and this
yeah.
might be your own personal advice on, what metric is the most crucial to increase. So we talked about the ones that go down, and is
Yeah,
there some aggregate metric that best shows the quality of your RAG? Great
good
question.
question. We will get to that, but we're right now right at the retrieval step. So let's maybe I'll address it in a following one, right? So, but now we have the relevance evaluations, and we actually passed it this really interesting flag. I just want to highlight. It's called provide explanation. It's totally optional, but it lets you understand how the LLM reasoned about the relevance of the document, and it's really helpful for troubleshooting. And we'll see that in a minute. So if we look at the retrieve documents, I unrun this. Uh-oh. I have to run it. Uh-oh. Oh, I'm up here. Okay.
This is the fun part of doing it live.
Doing it live, and now my notebook is dead. Um, Don't see an error.
It almost looks like it restarted.
Yeah, it may. Oh, yeah, I lost connection. Oh no. um,
All right, Mickey, well, maybe just go through and because now that we're in kind of like the second part of the notebook for the evaluation, so we have about 8 minutes left. So
yeah,
yeah, either rerunning or waiting or just kind of going through the notebook because folks do have it available that they can run on their
yeah,
own time.
yeah.
People are
Luckily,
joking.
we have our demo
Colab retrieved
instance.
your session and closed it. So
Yeah. So, well, let me just talk it over. And luckily, I have the cell outputs cached here, so we don't have to run it live. Um, but you can see, the documents with relevance are now here. So now we can look for each input, the reference text that was taken, and we can also see, it's labeled some of these as relevant or irrelevant. It's also given a 0 to each irrelevant document as well as a 1 for when it is relevant, and it has an explanation here. We can also calculate NDCG as well as precision, but these are also automatically calculated for you inside of Phoenix. And so I'm going to go to our Phoenix demo instance and kind of show you what this looks like. So if you now look at the retriever step, you can see that when we send these evaluations back to Phoenix, it can tell you whether or not each one of these documents is relevant or not, right? So this is saying the question is about hosting the service for websites with features like accelerated CDN delivery and usage data, but the reference text, on the other hand, talks about a deployment to Arise, a different service. So each one of these gets a score, and then we get the NDCG, in this case, 0. That's completely terrible. Also, we get a precision of 0, and this is no hits, right? None of these documents were relevant. And so if you send these evaluations back to the Arise platform, we're able to kind of calculate all those retrieval metrics for you. And in fact, we do aggregate as well. So you kind of can get the overall, your system's NDCG, as well as precision, hit rate, also like things like mean reciprocal ranking. So you can kind of look at your retrieval performance. You can actually filter down just by the retrievers, for example. Spelled it wrong.
yeah,
Are you
spelling
running low on
spelling
time?
sometimes isn't the coding forte.
Right. So now you can get a list of our retrievals, and we can kind of look at different problematic areas and try to understand what's going on there. But so great, we have a retrieval system, but we don't really know how it's impacting our overall application, right? And so, yeah, just to go over, you saw it in the Phoenix UI too, but even though we were supposed to be able to answer every single question, we still have an NCDG of 91, which is not perfect. It should be doing better than that. We also have a precision at 2 of 80. So there's kind of irrelevant information being put into the context window. So that's not ideal, right? You want as much relevant information in the context as possible. And also we're having a hit of 0.93. So there's still about 7% of the queries that are actually getting completely irrelevant information. So now we have like a benchmark. We have something, we have a target, and each one of these we want to optimize for, right? Because if you're giving irrelevant information to the LLM, it's going to answer things incorrectly. That's kind of if you teach your kid how to the wrong the wrong information, it's probably going to do the wrong thing. And so there's different strategies you can do to kind of boost this up, adding things like re-rankers or changing your chunking strategy. Maybe you want to fetch more than 2 and then filter out the irrelevant ones. And Llama Index has a bunch of great strategies there. To just kind of finish off this idea of response evaluations, right? Like it's great that we just did retrieval, but how's our LLM doing, right? Like our LLM might be able to actually be smart enough, it's like GPT-4 maybe, to actually course correct. It might actually be able to work around irrelevant information. Maybe, it can properly say it cannot answer the information, or maybe it will completely hallucinate and just make up an answer. And so for those, we have our response evaluations. And so in those cases, we can get the question and answer pairs with reference out of the Phoenix session. In that case, you're going to get the user query, the final LLM answer, as well as the context information that was used to perform RAG. And so now you have a data set that you can do response evaluations on. So in this case, we're going to run two of them. We're going to run hallucination evaluator as well as the question answer evaluator. And we're going to run that through our system. In this case, now it's like telling whether or not the LLM or the RAG system correctly or incorrectly answered the user question. So you already can see we have some incorrect answers. And in the case of the hallucinations, it's also shown that some of them have hallucinated, but most of them are factual as well. And so if we look at the aggregate metrics of our hallucinations as well as our QA correctness, we're about 93% answering the user question and actually seeing hallucinations, signs of the LLM making up answers in about 5% of the queries. And so you can always, once you've run these evaluations, log them back to the Phoenix platform and then visualize it correctly. And so let's quickly take a look at that. So if we go over to traces, let's filter down to those that are hallucinated. And so now we can quickly, just look at things that are related to hallucinations. And what you'll notice is that in the case of hallucinated, it almost always directly correlates with bad RAG, right? So now it's saying it's hallucinated, but the answer is correct. We can actually see under the evaluations an explanation of why it thinks it's hallucinated. So it says the reference text is empty, providing no information or context to validate the answer. Therefore, there's no way to confirm the answer. Yes is a test question. Okay, so this is not the greatest example. Let me give you a little more good example here, but you can see how powerful these explanations are, right? They tell you why the LLM has hallucinated. So it says the query asks about how to delete data. The reference text mentions deleting individual integrations from PagerDuty, but is actually not actually answering the question. So sure enough, if it's hallucinated, but then we go down to the retriever, we can see that both of the pieces of context are irrelevant. NDCG is 0, precision is 0, the hit is false, and that's actually causing degradation on our response evaluations. Now, this is a chatbot that's just blindly using RAG, kind of the similar way that we were doing in the notebook, and it's hallucinating at a very high rate and also not providing correct answers to our questions. So and go quickly back to the notebook. So yeah, with that, we've explored how to build and evaluate a RAG pipeline using Llama Index and Phoenix with a specific focus on evaluating retrieval system and the generated responses within the pipelines. So yeah, Phoenix offers a bunch of other evaluations. Amber kind of mentioned things like toxicity. We have things like human and AI versus AI evaluations. So definitely if you have questions about that or want more details, definitely check out our documentation.
Yes, thanks everyone for joining. We are at time. These will be recorded. The session will be recorded and sent out. I think we answered about 15, 16 questions from folks, but there are still more questions in here. I highly recommend asking them in our Rise community chat, and our Rise community Slack instead of the chat, and we will get to those. And thanks everyone. That was a great presentation. Thanks, Mikio.
All right. Thanks everyone.
Bye.